that, guys?
That was not easy.
Yeah, that
that
was
was such a hard test.
How did you do on the exam?
So really difficult. It wasn't very fun at all.
I don't
But
know. It
it's
gave
okay.
me like a score, but I don't really know what it means. What did Professor Smith say in class?
I think she said that we have to get in the 70th percentile, but I only got a score of what I got right out of the 70 points.
I think Professor Smith was going to give us our percentiles next week.
I don't know if I can wait that long. Wait, didn't we learn about percentiles in stats class?
Yeah, we did. We learned about standard distribution and z-scores.
We should go to the library and calculate it out.
Okay, let's do that. Okay guys, I think our first step is to find the z-score.
Wait, remind me why we need to do that? Well, a z-score is standardized, so it gives us a standard unit of measure so we can compare it to other scores.
Oh, okay, that makes sense.
Oh, okay, so we need the formula. I'll write it. The x is the data point. This is the mean and the standard deviation.
So the mean is the sum of all the test scores divided by the total amount of test scores.
Okay, and the standard deviation is the square root of the variance.
And the variance and the standard deviation measure how much each data point varies from the mean.
Okay, this is the data set for everyone's questions they got correct on the exam. Okay, let's calculate the mean.
So I added up all the scores and I got a total of 1,913, and then I divided by the number of students that took the test, which was 42, and I got a mean of 45.54.
Okay, so we calculated the mean, which is 45.54 for all 42 data sets. So the next step to finding the z-score is to find the standard deviation. So the equation to find standard deviation is one data point minus the mean square root divided by the number of cases minus 1, and then you square root that, and that's standard deviation. This is the equation right here for variance. So we need to calculate variance first. Calculating variance for all 42 points is a tedious task. So we're gonna calculate the first 10 to show that we can do it manually, and then we'll calculate the rest in SPSS. So I'm just gonna do the first point for an example for you guys to show you how to do it. So the first point is 56. So that would be 56 minus the mean. So we took the mean for the first 10 data points, which would be 43.5, and then you square that, divided by, we did it for 10 cases, 10 minus 1. Okay, so after calculating this equation, the variance for data point 1 would be 156.25. But then you need to find the standard deviation, so you would square root that number. So the standard deviation for data point 1 would be 12.5. So now we'll calculate the rest of them for points 2 through 10 to find the standard deviation for that.
So after adding up all of these sums, I got a total of 1,460.5, and then I divided that by the total number of students, which for our sample is 10, and I just subtracted that by 1, which gives me a total of 162.27, which is our variance.
Okay, so our final step is taking the square root of our variance. And that equals 12.74 for our standard deviation.
Wow, that was a lot of work. Although I'm glad we were able to recall how to calculate standard deviation manually. But let's look at the SPS software to determine the standard deviation for the original 42 students. As you can see, our mean we calculated is the same as this calculation. The standard deviation and variance are slightly different due to the fact that we only used 10 data points. We will use this standard deviation to calculate our individual z-scores. So I'm going to calculate my z-score. I'm going to start with my data point, which is 46, subtract the mean, which is 45.54. I'm going to divide all of that by our standard deviation, which is 10.43. And when I divide that, my z-score is 0.04. I'm going to start by looking at the column for my z-score in the tenths place, which is 0.0. Then I will go across that row until I find the number that corresponds to my z-score in the hundredths place, which is 0.04. That is where I will find my percentile is the 51st.
After calculating the rest of the z-scores, Emily had a z-score of 0.62, and after looking at the chart, she fell into the 73rd percentile. Katie had a z-score of negative 0.63, after looking at the chart, she fell into the 26th percentile. And I had a z-score of 1.58, so I fell into the 94th percentile.
Since Katie and I didn't get into the 70th percentile, what does that mean for us?
Yeah, I'm kind of a visual learner. Do you think a standard normal distribution curve will help us better understand?
Okay, so this is known as the standard normal distribution, or otherwise known as the bell curve. It is a great symmetrical graph to show the differences between our z-scores from that of the mean, which is at 0, and also our z-scores differing that from each other.
The mean is the middle of the z-score axis and is the highest point of the curve. It's also equivalent to 0 and marks the 50th percentile.
Negative z-scores indicate that that data point is below the 50th percentile, while positive z-scores indicate that that data point is above the 50th percentile. Any z-score more than 3 standard deviations away from the mean indicates that it's an outlier, and this can be on either side of the mean.
So I'm confused then, what does my score mean according to this graph?
Well, if you shade from left to right to your z-point, you can see that it covers 26% of the graph. That means that you scored higher than 26% of the class. Whereas if you shade to my z-point, it means that I scored 94% higher than the class. Good job, we passed.
Bummer, we failed.
Maybe we should go home and remediate.